All right, welcome, ladies and gentlemen. I apologize. That was very, very frustrating on my end. So, one thing, if you guys haven't noticed, and I apologize, please let me know. I'll make sure I have the chat up. So, if I am not sounding right or if there is a delay, my computer has been pretty wonky, but there's a good reason, which I'll explain why that has been the case. But thank you so much for joining on. Jose, good to see you. And Amanda, I see you on there. I'll get to your guys' questions here in just a second. But if you have any math questions, feel free to put them in the chat. Or if you have any general questions, feel free to put them in the chat. Or if you have a math question that you'd like for me to kind of work through, then you guys can go to brianmclogan.com/Q&A, which I am going to work through some math problems that were submitted by students. We'll get to that rather quickly, and then I will hang out and answer whatever question you guys have. So I'll go back through the chat. I always like to look through at least as many as I can. Don't spam the chat. I will promise I will look through them. I can't answer every question, but I'll try to do my best. So anyways, why is my computer being so bad? Well, a couple reasons for that. I kind of got a little stuck on my content strategy kind of formula, and I wasn't really feeling the rhythm of uploading 3 days a week. And I don't know what it was. I have stacks, ladies and gentlemen, stacks. Like stacks of papers of math videos that I get ideas and I want to create. And one of the problem that I had was I think only creating a couple of these videos, I would create some and then I would have weeks that I got busy and I didn't feel like I was in the math mode enough. And so I just kind of realized I was like, you know what? I think I need to go back to my daily uploads. And it's not for anything like I need to make, more videos just to make videos. It's like when I make videos or when I talk about math, I just get in the zone. And I think it just helps me think more mathematically and think about more content ideas and want to produce. And so far, I've been giving it a shot this last week. Posted every single day except for today, which is my live stream day, because I want to be consistent. I want to be like, hey, I'm not going to post a video on a Sunday. So therefore, you can expect me to go live. And if my schedule is so busy that I'm not able to go live, I'll go ahead and post a video. Because that's the way it used to be. For many, many years on my channel, I was always posting live content. And a lot of that was because it was just stuff that I made in my classroom. So it's fairly easy to record because that's what I did every day. And I would just upload it and stuff like that. And obviously, not being in the classroom, there's a lot more time and effort that goes into making videos. But um, I think that's also the struggle that I have is not being consistent making content. That leaves me with sometimes I'll have like a month laid out ready to go. And then, I'll get busy. I'll be working on some different projects. And then I'm like, oh crap, I got to now make some videos. But then it's been like maybe a month or two since I was looking at the content that I wanted to produce. And it just takes me a long time to get back into things. And so I feel like, just like a teacher, you should be doing, and just like I tell students every day, you should be doing math each and every day. That's how you're going to get better with math and understanding math. And so I think doing that as well from from my teacher's perspective is going to help me continue making content. Because one thing I've wanted to do is like say, hey, I'm going to start doing calculus stuff. I want to do more geometry stuff. And if I'm not consistent making math videos, I lose track of time to be able to get those done. So that is what we have there. So that's a little update. So anyways, why my why my computer has been taking so long was because I have so much content that I recorded. I uploaded it to get it onto YouTube and TikTok, and it's all on my desktop, and it's taking up all the memory on my video. So I do apologize. Oh, there we go. Am I still live? Didn't say that it stopped. It said the recording stopped, but I think I'm still live. I'm going to go and monitor the chat. If I'm still on this live stream, let me know. It was literally right as I said that I got a message from my software saying there's been an issue on your live stream and the recording has stopped. But I think that's just the recording. So I think the live stream is still on, but because I'm not seeing any issue with that. But are we still good? Yeah. All right. Well, I'm just going to continue on. Okay, cool. All right. Let's get to some of your questions. Then we'll get to the math and then I'll get back to your questions. So as I'm going through this, as I'm talking through math, feel free, guys, to add into the chat or go to brianmclogan.com/Q&A. Amanda, thanks for your help. I'm 35 years old, going back to school. I love that. I haven't taken a math class in 17 years. It's a struggle, but your videos help so much. Well, thank you so much. And yes, I can only imagine what it'd be like to go back to school after seeing math after 17 years. To be honest with you, even being a math teacher and doing so many problems, my daughter is, in third grade. I have another daughter in second grade, and I help them with their math. And even trying to like go back and like put my brain into what they should understand and how I want them to understand the numbers based on what they know and what they are working towards and how it's being explained in the textbook is even hard for me. It's a struggle. And anytime anybody asks me for math help that's kind of below high school, it's difficult because even though I have a math training, it's really for that kind of foundation from high school and above. And sometimes those lower grades, the way that they teach it and approach it, can be difficult because obviously I always want to go off of my experience of what I know, from a math degree and high school perspective. But you got to put yourself back into their shoes of what they understand, what they know, and use the tools that way. So kudos to you though for taking on the challenge. I know if you just keep on putting in the work, just like anybody else, you can be successful and you can do it. Let's say, hey Nan, thank you, greatly appreciate it. Well, thank you very much. Is math a workout, but mentally for your brain, similar to a physical exercise? I would probably say so. I mean, I think it's always, they always say like when you get older, you should be constantly, working on crossword puzzles or making your brain work. I can't tell you how many times I had study sessions where I just had to quit because my brain like had that same, like, it was just exhausted of me thinking through, through the problems and working through the problems and stuff like that. I do live streams, or even when I do these live streams, like after I do a couple questions, my brain just gets fried. Now, a lot of that is talking, to a screen, but just doing math. Like I have some videos where I did like a 4-hour live streams working through a pre-calculus final. And I can tell you, like, by the end of those videos, my brain just felt like completely fried. So yeah, I would say very, very similar to there. You know what? I used to hit the gym every single day. I didn't have great numbers, nothing to brag or bring home about. But my back I had a stress fracture in my back when I was in high school. Playing rugby in college and after college did not probably help that injury. And so, yeah, I've had to take a break away. So kind of gain some weight. I want to get back into it, but it is what it is. Okay. Awesome. I will go ahead and take a look at that. Arav, good to see you on as always. I'm a middle school student and I really appreciate your work. Well, thank you very much. Okay. So let's go and get into the math. I will pull up oh man, that was on my laptop. Dang it. All right. Well, I will make sure I'll try to get to this at the end. Let's get 5%. So, all right, let's get this open, enter full screen. Bam, sweet. All right. Let's open this here. Awesome. Okay. I still have your comments in, so no spamming, ladies and gentlemen, but I'm not going to answer comments directly from the comments or just individual questions because I'm just going to knock out some math because we love to do some math on these Sunday evening live streams, getting you ready for the week. But then after that, I will get to these questions. Okay, I promise. All right, let's get this. Can I put this over here? I can. Sweet. I want that up there. There we go. Just want to get your comments on my screen. Okay. All right. Let's see if my math pen is working. All right, cool. Hamza, I missed a few days of PF school and I have no idea how to do this. I think it's about sketch the general shape of each function and describe the intervals in terms of positive, negative, increasing, and decreasing. So let's work through number 12 because that would be a lot to do both of these. Um, and yeah, there's a lot of things you can understand about increasing, decreasing your intervals, where the graph is going to cross, the end behavior. I think those are all very, very important parts, or if those values are going to be um, intervals in terms of the positive and the negative and stuff like that. So we'll talk about that in all throughout this. So here's going to be, our general function. And typically when we're looking at just the general function, we're looking at the zeros and we're looking at the end behavior. Okay. Now, immediately just looking at this function, there's one thing I know. I see that my degree of my polynomial is odd and my leading coefficient is positive. So therefore, I know this graph falls left and goes ahead and rises right. All right. Um, now, we're not talking about the zeros, or doesn't look like you're interested in finding the zeros, but the zeros, again, are going to occur when f of x is going to equal 0, or when those values are going to make f of x equal 0. Now, just real quick, I can see there is a 0 if I factor out in x, I'll have x to the 4th minus a 3x squared plus 3, okay? So I do know that x equals 0 is going to be 0. That is going to be an x-intercept of the graph, all right? Now, again, it's not part of your question, but I think there's just some important things that I want you to kind of recognize here, at least about f of x. So, and then all the other zeros, looks like if I was to even do that, those are going to be probably irrational or complex, meaning you're not going to have any real x-intercepts, or you could have some, but they're at irrational values. All right. So that's what I know about f of x. Now let's go and take a look at what about if we look at f prime of x, or what you call the derivative of f of x. That is going to tell us about the slope or the change of this graph when it's is going to have a positive slope going over to a negative slope. Now, where that's going to change is what we call our critical values, and that's going to be when our derivative is equal to 0. So we have a polynomial here. Let's go ahead and find the derivative here of this polynomial. So therefore, I can bring down the power. So that's a 5x to the 4th minus a 3x squared plus a 3. All right. So again, if we want to find the critical points, that's going to be where the slope is changing from positive to negative or negative to positive. We want to figure out the critical point is when f prime of x is going to be equal to 0. So let's go and do that, and let's see if we can factor this. That would be ideal. 5x to the 4th minus 3x squared plus 3. So looking into factoring this, if I had forget about the force, let's just think about this as quadratics, okay? Let's pretend this was like a quadratic function, and I just want to see if I could do that and then raise the powers. And so I don't want to get 15, so that'd probably have to be a positive 3 and a 1. But I'm seeing if I multiply 5 times 1 and then 3, 2, that's going to have a difference of 2. I need a difference of 3. Plus, this is be positive, so that means both these numbers have to be both negative or both positive. This is not going to be factorable. And so that's going to cause an issue, because if something's not factorable, or at least, factor across our real rational numbers, what can we do here? Because it's raised to the 4th. We can't use the quadratic formula unless we we just use substitution. So what I see here is, what about if we had, this is in that form of that in like a quadratic with the powers are going to be raised. So I could use the quadratic formula if it looked like this: 5u squared minus a 3u plus 3. So therefore, we could say 9, negative 9. Where did I put a negative 9x squared, not negative 3? Oh, yeah. Thank you very much. Yes, you got to bring that down. You have to take the 5, subtract 4. 3 times negative 3 is a negative 9. Thank you. And then that's a 3. Yep, thank you. So what we're going to do is we're going to use substitution to use the quadratic formula. So I'm going to say let u equals an x squared, right? Because then if you think about it, a u squared would be a x squared, which gives us our x to the 4th, which is exactly what we have here, okay? So I'm just going to do this just so I can now use the quadratic formula to go and solve. Then I'll plug the x squared back in, and that will help us find our values for our critical points. So let's see, I'll have u is equal. So that's going to be opposite of b. So remember quadratic formula, opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Make sure you know the quadratic formula. It's so important. I actually have a video. Did I already make that video? Yes, I did. I have a video that's coming on. And one of the main formulas that I just highlight to students is like, know that quadratic formula. So that's going to be 9 plus or minus the square root of -9. I'm just doing this for accounting reasons. Squared minus a 4 times a times c divided by a 2 times a. All right, so that's going to be an 81. 4 times 5 is 20 times 3 is going to be 60. So we have 9 plus or minus square root of 81 minus 60 divided by 10. And 81 minus 60 is going to be a 21. So therefore I have a 9 plus or minus a 21 divided by 10. Okay, but remember that's u, right? So now, come on. So now we figured out what u was, but remember u equals x squared. So I can now replace my u back in with my x squared, and then to solve for x, guys, what are we going to do? We need to now take these. Actually, let's use a different color for that, just so you guys can see that's not, I'm adding that in. So now I let u equal x squared. So now let's take the square root of that, and now I'm going to have 4 solutions, right? Because this is a plus or minus already. And then when you introduce the square root, guess what? You also have plus or minus. So x is going to equal a plus or a minus of the, let's do the positive version first, 9 plus a square root of 21 divided by 10. And then x equals a plus or minus the square root of a 9 minus a square root of 21 divided by 10. Okay, we can leave these as exact values, but that's not very much fun because when we're dealing with our critical points, there's a couple different ways we can do this, and I'll show you the fast way at the end. But what we want to be able to determine on our derivative is when we plug in different values, are they going to be positive or negative? If they're positive, that tells us our slope is going to be positive of the original function. If those values are negative, we can tell that it's going to be negative. So we want to be able to determine, well, which integer should we use for the test points? So we need to kind of get a decimal equivalent here. So let's just go ahead. I got my TI. I'm just going to work through this. So let's do square root of 21 plus 9 divided by 10, square root of that answer, and I'm getting a 1.165. So x equals plus or minus, actually approximate because I'm just going to round this to 1.165. And then let's do this one. So 9 minus square root of 21 divided by 10, square root, second answer, 0.66. So x equals a plus or minus a 0.66. Okay, so here's going to be my critical points values, all right? And what we're going to do is we're going to create a nice little chart, or I'm sorry, a number line, okay? So we're going to have 0, and we're going to have 1, and we're going to have -1. Okay, so let's go and take a look at it. So I can go ahead and I have a critical point at 1.16. So that's going to be like negative and positive. And I also have one at 0.66. So that'd be like from right there, and a positive 0.66 from on there. So what I'm going to do is I'm going to use some test points. So you can see -1 and 1 are in between there. So my test points here are, I'm going to do let x equal a -2, a -1, a 0, a +1, and let's go ahead and do a +2. Because what I want you to see here, and let's say here's -2. All of these we want to see, is this positive, negative, positive, positive, right? We want to look at all these different options that we could have. So what you're simply going to want to do is take these values and plug them in to your derivative function to determine, are those values going to be positive or are those values going to be a negative, okay? But to save the sake of this video, to not make this extremely long, because yeah, all you're simply going to do is plug this value in, plug -2 into this derivative function. Where is it? Right there. Plug it in and see if you're going to determine if you're going to get a positive or a negative number. Now, I'll just do 1, okay? Just because I want to show you what we're doing, but I'm not going to do them for all of them because there's a little trick that you can use, but you got to be careful. You got to know the important things. But since we're dealing with polynomials, there's a little trick we can kind of use. Okay. Okay. So in this case, if you were to plug in a -2 squared is going to be a 4. So 4 times 5 is going to be a 20. So again, you just, let's see, if we plug in, so that would be, so if I, let's do this as f prime of x. Okay, and then we'll do f prime of -2. Okay, so that's going to give me a 20 here. -2 times a -9 is going to give me a positive 38. That's going to be a 41. So that's positive. So that is going to be a positive value in this case. Now, actually, well, yeah, that was what I already knew from on there. We're just gonna have to work through this. Because yeah, you don't want to assume, because you could have a positive again to a positive on these. It could be not a inflection point, so we do want to test them. But I think the important thing, yes, I spoke wrong. But the one thing I knew, the reason why I knew this was positive is because I knew what the end behavior of this graph was, right? That's the kind of trick. Remember, if you're going all the way down to infinity, I know this slope has to be going up. So I know that's going to be positive. That's why I knew that one was going to be positive. Now, in this case, you could have these little S curves of this graph. So it still could be a positive and as well as another positive. So that's why we would still want to go ahead and test all these different values. So let's do f of f prime of -1. If I plug in f prime of -1, that's going to be a 5 plus a 9 plus a 3. You can see that's going to be a positive. Let's go and check f of 0. So f prime of 0. That's going to be 0. That's going to be 0. That is going to equal a 3, which is again is going to be a, oops, that's positive, and that's positive. And then let's go and check in a +1. Well, now if I go ahead and check in this +1, so let's do f prime of 1. F prime of 1 is going to be, so 1 squared is 1 times 5 is a 5, and then minus a 9 plus 3. So that is going to be a negative, right? Because that ends up giving us a -1. So from 5 to, so for 1, that's going to be a negative. And then let's do our last one, which is going to be 2. So f prime of 2. And so when I plug that in, that's going to be 4. So that's going to be a 20. A 2 times 9 is a -18. And then plus 3. And you guys can see again, in this case, that's going to be a positive value. So again, we're going to be back positive. So if you want to go ahead and look at, the intervals that this graph is going to be increasing, you can see it's increasing on this interval. Now, again, these intervals right here, this -1.65 is like right there, right? And then right there. And then 0.66, that's this one like right here. That's the -0.66, and that's the +0.66. So depending on your teacher, on how they're asking for you to go ahead and do that, you can go ahead and label them in the exact manner, and then you can write those on there. But you can see that this graph is going to have a increasing in a positive value. The f prime of -1 is less than 1. F prime of -1 is less than 1. Where did I make a mistake? How is f prime of -1 less than 0? Because -1 squared is positive. That's positive, and that's 3. So let me know down in the chat if I made a mistake on my prime. I don't think I have from on there. But let me know, and I can definitely come back to it. But that would be sketch your graph in terms of the intervals. And so how do you, if you look at the derivative without u sub? Well, did I grab the wrong derivative? Oh, I'm an idiot. I did grab the wrong derivative. Why didn't you say that? I grabbed the wrong derivative. You got to be kidding me. I wasn't paying attention. I grabbed this one that you said. That's not the one we can use. Oh, jeez. Come on, Araf. That's what I was expecting for you to show up and And catch me on this. I just was not paying attention looking at it. Yes, I will go ahead and repeat back in from on there. Okay, so once we find our derivative, again, the values when we plug them into derivative are going to tell us the slopes that we have of our original function, if they're going to be positive or if they're going to be a negative. So when we go ahead and plug them in over here, now I know at -2 is going to give me a positive, because you can see this -2, you can see this -2 to the 4th power is going to be a really, really big number. That's going to be what, 816 times 5. This is never going to be negative, so that's positive. Yeah. Well, it does. Yeah, you can see it makes a big difference here on -1, because that -1 squared, that 5, and then that would actually be a -9. So yeah, you got to make sure, do not do the U sub, because we got to look at the definition, or the pure definition of your derivative. And honest mistake by myself, I apologize. So that one actually is a negative. So at -1, we're actually dealing with a negative interval. But thank you for being it, because I don't care. It's not I don't care for mistakes. I am human, so I'm going to make mistakes as well. And then we have f prime is 0. Let's make sure that one still works out. 0, 0. Yep, that's good. And then we look at f of 1. Now, f of 1 is going to be that negative, right? And then we have that 2, which again is still going to be positive. So we have positive, negative, positive, negative, positive. And there you go, ladies and gentlemen. That is how you identify the intervals for increasing and decreasing intervals of a polynomial using the derivative. I don't know why this got messed up. So let's go and fix this one for the student. Okay, there you go. I was wondering why that happened. Okay. Todiwo. I'm not sure if that's your name, but let's go with it. Hi, Mr. McLogan. I have a test tomorrow about radical expressions, and I'd really like some help with this practice problem. The answer I got was 3/2 p raised to the 5/12 q r raised to the 3/4. But the answer key says it's 3p raised to the 7/12 r to the 1/4, 2p divided by 2p qr. I really applaud all of your work as you've been carrying me through mathematics. Well, you are very welcome. Now, interesting. This is a simplified version. This does not seem to, like, so if this is all divided by, you can see, I don't know what it looks like. I'm not sure what how the question was framed or the directions were framed, but you can further still simplify this question. So I'm just confused on what the directions were for this problem, because if this is written as p raised to the 7/12 r to the 1/4 divided by a 2pqr, you can still simplify this, right? We can think of p as to the first power as 12 over 12. So if I did this as 3 p to the 7/12 r to the 1/4, and then if I want to rewrite this as a 2p to the 12 over 12 q r to the 4 over 4. Now I can apply my rules of exponents, and I'll subtract this, and I would get a 3/2 p. Again, remember when you're dividing exponents, you're going to subtract the powers. So that's a 7/12 minus a 12/12. And then over here, I have an r to the 1/4 minus a 4/4. And then we still have our q, right? So my final answer, anything positive goes in the numerator, anything negative goes in the denominator. This is going to be a p to the negative 5/12. So we'll put that down here. And this would be a negative 3/4. So r to the negative 3/4. And then I think actually q was already down below. Yeah, and q, it was 1 over q, really. So then q is actually already down there in the denominator, because that's how that question was written. So let's see. Oh, no, not a negative. Sorry, guys. Those are not negative. They were negative, but that's why we put them in the denominator to make them positive. There you go. All right, so let's just see. Is that the same answer you got? Yeah, that's exactly what you got. So I'm not sure why the answer key was non-simplified. Now, for the sake of mathematics, for those of you that maybe are like, well, how would you even do this problem anyways? Let's just kind of work through it, at least how I would like to approach it. So when I work through a problem like this, we're going to use the rules of exponents. And what I always tell my students to do is there's a lot going on here, and especially when you're looking at fractions, this can look very, very confusing. So what I'm going to focus on is just doing the problems that I know how to do, or just focus on each thing separately. Okay. So anyways, you're not crazy. It looks like the answer key was just not simplified. And again, I don't know why it wasn't. I don't know what the directions were. But if I was given this problem, what I would do is I would say 24 over 16. Let's do that first. Then let's go to 2, which is going to be, again, now here, before I go and do the math, I don't like negatives. So when I have an exponent with a negative power in the denominator, I'm going to put that in the numerator to make it positive. Whenever I have an exponent with a negative power in the numerator, I'm going to put that in the denominator to make it positive. So I would rewrite this as a p to the 1/4 divided by what? A p to the 2/3. And then number 3 is, I'll just do that as a q to the 1/3 divided by, what was it? Q to the 3/4. So q to the 4/3. And then there's nothing we can do with that r. Well, actually, we can put the r in the denominator, right? So that's 4. I'll write that as positive. So r to the 3/4. Put that in the denominator. Okay. All right. So let's go and see what we can simplify here. What is the largest number that evenly divides into 24 and 8? 24 and 16. That would be 8, though. So I can divide the top and bottom by 8. And therefore, that's going to, I don't know why. Come on. So that would be a 3/2. Over here, I'm going to have to subtract the power. So that's a p to the 1/4 minus a 2/3. Now, for this case, we're going to have to get a common denominator. The common denominator is going to be 12. So I'm going to multiply by a 3/3 and a 2/2. That's going to now give me a p to the 3/12 minus a 4/12. That's not right. That's not going to, I need to multiply by 4. What am I doing? Now you can't read what that is. So let's fix that. Okay, so you need to multiply by 4 on the top and the bottom. Okay, so that's going to be an 8/12, which is going to give us that p to the negative 5/12. And again, remember, that's negative, so therefore I'm going to put that in the denominator, right? So I can rewrite that as 1 over p to the 5/12. And then this one, we're going to do subtraction. So q to the 1/3 minus the 4/3. They have the same denominator, so that's awesome. That's going to give me a q to the negative 3/3, which is equal to a q to the negative 1st, which is equal to 1 over q to the 1st. Okay? And then I already did the r cubed. So it looks like that's in the denominator, that's in the denominator, that's in the denominator, that's in the denominator, or that we have 3 in the numerator. So my final answer is going to be a 3 divided by a 2. Let's gonna do, I want to do them smallest to largest. So p to the 5/12, r to the 3/4, and then q to the 1st power. Voila, there we go. You were right, so don't worry. Rohan, hey, Miss McLogan, I have a test tomorrow. Best of luck. And really need help with this problem. You need to find the inverse and determine whether or not the inverse is a function. Can you help me with this problem? As the answer key states, it's y equals 3x squared minus 2 divided by 4 when x is less than or equal to 0. However, I do not really understand how to reach this condition. I also do not understand how to figure out whether or not the inverse of f of a function besides graphing it. So if there is a way you can do that without graphing, please show it off. Thank you. There is, but it still comes in with an understanding of the graphing, in my opinion. So if I apologize, guys, it's been a couple years I've been out of the classroom. I believe for a function to be invertible and for that inverse to also be a function, it needs to be not only 1-to-1, but also it needs to be 1-to-1 or onto. I can't remember the definitions. I apologize. It's been too long since I've been teaching this. But let me show you what I would go over and teach my students. Okay. And basically what that means is if it's going to, it has to pass that horizontal line test, at least if it's going to be invertible from on there. But let's go and take a look at this. Okay. So in this case, I have f of x equals negative square root of 4x 4x plus 2 divided by 3. Okay, so let's just kind of understand what this graph looks like. And let's kind of go through an example of inverse functions first, okay? Because I think if you have an understanding of inverse functions, that will kind of explain why we're adding in this, what we're doing here. And I'll actually copy, paste. Okay, let's do this twice. So let's start off like I was teaching a class, and let's just do something that we kind of hopefully are all familiar with, and that would be a line, okay? So if we had a line, and if you remember, we want to find the inverse, there's a couple ways that we need to understand functions that are inverses of each other. The first one is going to be their points x, y are swapped. So if this is my x and that's my y, then if it's like over 1, up 1, 2, 3, 4, now I could say this new point is 1, 2, 3, 4, up 1. Okay, so the function in its inverse, if this is our f of x, my inverse function, the x and the y coordinate are swapped. Okay, we're going to swap them. Now, the other cool thing is that if you run that graph through those points, it probably looks something like that. Okay, what I want you to see is there is a line of symmetry of a function and its inverse. Okay, so if you're talking about like not being able to graphing, yeah, you can kind of like understand that. They're symmetrical about what we call the y equals x line. Okay, so let's go into your graph. And the cool thing is you don't need to know how to graph exactly what this is. You just need to understand the general transformations. So what I see in this graph is I have a negative on the outside, and that's telling me there's a reflection about the x-axis. Okay, so this graph is going to be reflecting reflecting around the x-axis. So the parent graph looks like this, right? That's just f of x equals the square root of x. Now, if I put a negative outside of it, that's going to reflect it about the y-axis. And then all this mumbo jumbo in here, right, is going to be my horizontal compression, I believe. I'd have to look at it. But then also there's a horizontal shift to the left, right? Because remember when you're adding inside of a function, that's shifting it to the left. I don't know where this graph looks like or what it is, but I do know it's probably going to look something like this. Okay, that's what that graph roughly is going to look like. Now, let's just play a game here, and let's go ahead and reflect that about the y equals x line. So if I was to reflect this about this y equals x line, okay, so sometimes I know, guys, it gets kind of confusing, but this point, remember, these points are swapped, right? The x and y's are swapped. So if this is like, let's say negative 2, 0, then this one's now going to be 0, comma, negative 2. All right. And then if you were to open that, it would probably look like this. And would you guys agree? Like that symmetrically, that kind of works. Okay. So I think that's important to be able to identify your inverse in this case. Now let's go and identify let's go and calculate the inverse. And that'll help us understand those restrictions that we're dealing with. So remember to do the inverse, you're going to replace f of x with y. That's the first step. And then you swap the x and y. Why do we swap the x and y? Because the graph and its inverse are reflections of each other, right? I mean, they're swapped. So it makes sense of why we do that algebraically. So x equals negative square root of 4y plus 2 divided by 3. And now, ladies and gentlemen, we just need to go ahead and solve for y. So first thing I'm going to do is multiply by negative 1 on both sides, or divide by negative 1. Doesn't really matter. That's going to give me a negative x is equal to a square root of 4y plus 2 divided by 3. Now I need to get rid of the square root. To get rid of the square root, I'm going to square both sides, and I'm just working through this step by step for you. I hope you appreciate it. So I have x squared equals a 4y plus 2 divided by 3. I can get rid of the denominator by multiplying by 3 on both sides. This is a lot of steps, so I'm just talking my way through it. So I get a 3x squared is equal to now a 4y plus 2. And now I'll simplify this. You're going to subtract the 2, divide by 4, right? So therefore, I have a 3x squared minus 2 divided by 4. And now that's equal to 0. But again, that's really what is equal to our inverse function. So, or sorry, that's equal to y, right? Sorry, not zeros. That's equal to y, but that is going to be our inverse function. So what I'm going to do is actually write this like a quadratic, because it is a quadratic. So I'm going to use inverse notation, not y. And I'm going to rewrite this as a 3/4 x squared, negative 2 divided by 4 is a negative 1/2. Okay, now do you know what this graph looks like? I hope you do. This is a quadratic. Is there any horizontal shifting? Is there any adding or subtracting inside the function? No. So if we look at this graph, we know that they're shifting the graph down a half a unit. Okay. But then, and then it's going to have a horizontal compression of 3/4. So the graph looks something like this. Okay. Now here's the problem. Does this look like the inverse graph of this? So what we basically have, ladies and gentlemen, is we have a graph that looks like that. Is the green graph a reflection of the blue graph? Yeah, part of it is. Well, what part is a reflection of the graph? Oh, only the x values that are going to be less than 0. All of this over here is not part of the inverse function, because then that would not be, the graph would not be invertible in that regard. So therefore, we cannot consider those positive values. We can say, yeah, this is the inverse, but only for x values that are less than or equal to 0. So that is why we have that restriction, at if it's going to have a restriction or not. And you can see if you're in if it's creating a quadratic or something that's going to fail the horizontal line test, then I would look into using those reflections. Or if you're creating a new function in that regard, that's why you'd want to look into it. So that's an example of that. Those are the questions that I have from you guys submitted. I'm going to take a quick little break of doing some math. Let's go and get over to your guys' chat. And then if you submitted already to brianmclogan.com/Q&A, I will try to end the live stream with what you guys have. But I do have to open that. Form back up again. So we'll see how my computer likes or doesn't like that. Let's go for it. All right. Open live Q&A. Let's see. We'll see how bad this is. We'll see how to go. I don't like how I can. All right. Nina. Same here. Over 40, went back to school. Congrats to you. The last class I need to graduate is trig. I'm struggling. Any videos always help. Any tips to maintain identities engraved into my brain? Write them down. Every single time you're doing a problem, write down what the identity is, right? I think that's the easiest way for you guys to understand any formula. You don't need to do flashcards or any kind of memory tricks. Just when you're going to apply a formula, write down the formula first and then go ahead and use it to apply. And I'm telling you guys, from being a math teacher, from doing math problems every day for year after year, I never practiced memorizing things. I had them ingrained in my brain because I was constantly writing them down on the board for students, to have in their notes and blah, blah, blah. And so I'm just telling you, when you go through that motion of writing down the formula every single time you need to use it, or maybe if the problem that you might be able to use it is you continue writing down those formulas, they're going to be ingrained in your brain. So hopefully that helps. Great question. How can you study for a test with hard questions that aren't in the notes or review? You just got to keep yourself exposed to different types of problems that you would not expect. Maybe look at some different texts. I mean, the cool thing, guys, now is you have AI, right? I mean, I never had AI. I used to tell students, go and get a textbook and look at the problems in the back of the book, or maybe go on the internet and see if there was another, some other hard problems that you'd have on some, janky website that somebody created. Now you guys can go to AI. You can see like what are maybe even feed it like your study exam, or feed it some different information. Say, what are some difficult questions that that I've never seen before, or that would be great for the teacher to ask on our exam, and then focus on practicing those. Like that's really, really important for you to get exposed. Okay. We're lagging. Yes. I think I added it. Okay. So this is something important to kind of thing. It says, I feel like using AI is a bit risky as reliance causes laziness and makes the brain forget how to absorb information independently. So I'm not sure how you took for me using AI. The student's question was, how can I prepare for harder questions that are not in my notes, that I don't know what to expect? And that's what I was using AI for, is like using AI. Hey, AI, create some difficult questions that maybe even you could upload all of your notes, upload all the content and be like, what are some really difficult questions that I would not be able to prepare for? And like, how can I prepare for them? So you're not just having AI do your math for you. You're having AI create some questions based on what you're learning of some difficult problems. Because yeah, you're right. If you're just relying on AI to do the solving and to understand things, then you're not gonna build up those problem solving skills for when you have a test and you need to work through it. You have to have your brain go through those motions. You are absolutely correct. Extremely important. But there's nothing wrong with AI creating a problem set that you can go and use to work through. There's nothing wrong with that. And so I don't see that as anything risky. I see that as something very, very beneficial. Yeah, no worries. I kind of made sense the way that how you framed it. Yeah, ladies and gentlemen, AI is awesome, but if you don't know how to think for yourself, you're going to be in trouble. Um, yeah, I found AI to be, I found AI to be bad at math. However, I never bought in, so maybe that's a difference. But I'm quite reluctant to trust answers, which I find often to be incorrect. Yeah, absolutely. I think there is now some um, math A bots that are like specifically just focused on doing math. I actually haven't tested them out, but and still, even if you're going into like websites and stuff like they have powered by AI, everything's going to make mistakes. And again, guys, if you're relying on you know artificial intelligence to be doing everything for you, then you're going to be reliant on them. And what I mean by that is, like, if you're reliant now to be able to get some basic stuff, then you're not going to be able to know what they're doing or what their inputs are to ensure you understand their outputs. So yeah, you got to be able to think for yourself. You got to understand, how to detect if they are providing you incorrect answers or not. Because if not, then you are at the whim of what they tell you, and that's only going to continue to grow, like it or not. Um, Cool. All right. Yeah. I don't know. I mean, it only started, in my opinion, guys, got really bad once I did. But anyways, I apologize. I know I really want to get to this Google form, guys. I have a ton of math videos that I made this last week that are all on my desktop that I need to upload to YouTube and delete them off here. So therefore, I can answer your guys' questions, or I can open up my second tab. But my computer is running really, really hot right now. So I apologize for that. I'm going to close down the stream for tonight. Um, but I will hopefully be back for next week. I'll let you guys know and we'll get to it. All right, guys. Cheers.